Welcome friends, today you will learn how NASA will launch an earthquake forecasting satellite in upcoming missions. As you continue watching the video, go to the logo of the channel in the bottom right corner and click subscribe button. Friends, NASA is launching a prototype device that can make it easier to monitor volcanic activity and the quality of air. It will be located about 300 miles or 480 kilometers above the Earth's surface aboard a CubeSat. This Nanosat Atmospheric Chemistry Hyperspectral Observation System, or NACHOS, will use a compact hyperspectral imager to map the sources of trace gases. It will operate under a smaller area of 0.4 square kilometers. NACHOS is a part of Virginia's Wallops Island, NASA's Wallops Flight Facility, under the 17th Northern Group resupply for the International Space Station. If it succeeds, NACHOS will monitor atmospheric trace gases such as sulfur dioxide and nitrogen dioxide. It will be the smallest, high-resolution space-based instrument, and in the future, it will open the way for Earth observation systems. It will not only help predict the volcanic eruption, but will also monitor air quality around large cities, neighborhoods, and even private power plants. A sleeping volcano emits sulfur dioxide shortly before waking up. From this, it can be known whether there is any detectable seismic activity or not. At the National Laboratory of the Department of Energy, Los Alamos, engaged with the Space and Remote Sensing Group, a researcher and task leader, Steve Love said, "This gives us the chance to first identify potentially explosive volcanoes before they become erupted." Whether from natural or man-made sources, atmospheric trace gases have provided scientists with a unique understanding of the Earth system in a wide variety. For example, nitrogen dioxide, which often comes from burning fossil fuels and harms human health, can serve as a tracer for carbon dioxide, which is a greenhouse gas and contributes negatively to climate change. Steve Love said that, when we believe that these gases exist, and their sources could be founded on a sub-kilometer scale, we can figure it out, we would have the opportunity to take action and reduce negative health outcomes. But for trace gases monitoring, and to collect high-resolution data, more sensitive equipment is required. This means we have to build bigger satellites, bigger than a whole house, with powerful sensors. Steve Love said, "We have some good satellites to collect data on atmospheric trace gases by staying in orbit, but they are expensive to produce and maintain. So, we want to increase this scientific capacity, and we are trying to make this technology cheaper." Weighing just 6 kilograms, and having an area of 300 cubic centimeters, NACHOS can be the solution to this problem. NACHOS is not only capable of gathering high-resolution data, but also uses a NACHOS onboard processing algorithm, in addition to an ultra-compact hyperspectral imager, which makes it easier to relay data transmissions back to Earth, and also reduces the time taken. These algorithms run smoothly on smaller computers, giving NACHOS a large amount of computational power, without increasing the size or weight of the equipment. With more power and less weight, NACHOS is believed to be an excellent satellite, which will explore atmospheric trace gases on different missions in the future. NACHOS will remain on the Cygnus spacecraft of the Northrop Grumman until May 2022, and when the spacecraft undocks away from the International Space Station, it will enter the Earth's atmosphere, leaving NACHOS in low Earth orbit. Steve Love and his team will spend 3 months commissioning the satellite before using it for technological validation and science missions. He hopes that NACHOS will remain in low Earth orbit for about a year. Love said, "This will give us enough time to verify the design of our solution and to collect testing data, so we can see how successful our research has been." Another report has emerged that a second Nachos instrument will be released in the low Earth orbit in the winter of 2022 as part of the U.S. Department of Defense space testing program. Friends, do you think that human beings will be able to achieve the technology that can detect an earthquake before its eruption? Write down your answer in the comments section, and also write down the information you need so that we can satisfy your curiosity. If you liked the video, just share it. Thank you for subscribing.